All right, mathletes, here we are looking at problem solving with trigonometry. We are looking at bearing problems and three-dimensional problems. So with bearing problems, we need to understand that our compass here, if we look here, we're always going to treat north as straight up on our paper, okay? And oftentimes that gives a measure of 360 degrees or 0, okay? We're going to think of true east to the right of our paper, and that's going to be 90 degrees from north. We're going to think of straight down as south, 180 degrees, and west being 270 degrees to the left of our paper. Notice we're going to look at problems where our bearings is not necessarily just going to be in those nice 90 degree increments, but we can have all different angle measures from 0 to 360 as far as bearings go. Okay, so if we're looking at a bearing problem, typically we're going to redraw kind of our compass and our axes at each point, and often we do that with dotted lines. And again, north is always going to be on the top of our paper. So often we always write bearings with 3 digits. So instead of 72 degrees, we write it as 072 degrees. Okay, and so that would be the bearing from A to B. Okay, but notice if we were going from B to A, okay, that's a different bearing. The nice thing about those is they always differ from 180 degrees. So we take our 72 degree angle and we add 180 degrees to it. We're going to see that's 252 degrees. Okay, so 252 degrees from north, we're going to be headed off there. We can see from our compass there, 252 degrees is west by southwest, and we're heading in that direction. Okay, so let's look at an example here. We'll start off basic with just true south and true east bearings. So we're starting at point A, okay, and we are going to head due east on a motorbike at 7 kilometers. So we head due east for 7 kilometers. So east is 90 degrees from our north. So we draw a straight line to the right. At some point we stop after 7 kilometers and we head due south. So south is straight down the page, and that is going to form a 90 degree angle. Okay, and we're at C. And we want to find the bearing of C from A. So we want to know if somebody started at the original point and wanted to come to us at the end, what bearing would they have to take? So what is this angle here? Well, first what we're going to do is we're going to solve for theta because we have a right triangle here. So we're going to solve for that. So of this theta, I know my adjacent side and I know my opposite side. So since I'm solving for an angle, I'm going to use inverse, and opposite and adjacent is tangent. So I do tangent inverse of my opposite side, which is 3 over 7. Okay, and as I put that in my calculator, I'm going to get an angle of 23.2 degrees. Well, looking at this problem, I want to know this bearing, so I have a 90 degree angle here at which I have to solve to find this angle if I wanted to go from point A to C. I know that this is east by south, okay, but it's in between, so I got to find that. So if I add 90 degrees to that, okay, I end up getting 113.2 degrees as my final bearing of C from A. Okay. Let's look at another example here. So in example 2 here, we got a rally car driver travels on a bearing of 140 degrees. Okay, so as we draw our start point, okay, we're going to think of a compass, okay, and a compass bearing. So 145 degrees, we're going this far. Okay, we know that from north to east is 90 degrees. Okay, it's not quite south because it's not to 180 degrees. So then this angle in here must be 55 degrees. We get that by subtracting 90 degrees from our original 145. Okay, we travel in this direction at 28.5 kilometers. Okay, how far east of the starting position is the rally driver? So how far east is going to be this direction here? That's our unknown. Okay, so again, it's convenient. I have a right triangle, and I'm going to think about what I know. So I know my angle of this right triangle, thinking of it drawn here. Okay, I know my hypotenuse, and I want to know my adjacent side. So what trig function deals with adjacent and hypotenuse? Well, that's going to be cosine. And of my angle of 55 degrees is equal to a ratio of sides, which is going to be x over 28.5 kilometers. Put this over 1 and I cross multiply, and I see that x is equal to 28.5 times the cosine of 55 degrees. And using my calculator, I got 28.5 times the cosine of 55, and I see that x is equal to 16.37 kilometers east from the starting point that we traveled. Okay. There's an example there. So look at an example dealing with three-dimensional problems. Okay, so just like with our Pythagorean theorem, we're going to probably have to look at a couple different triangles here with three-dimensional problems. Okay, so a cube has sides of length 10. So I know all three dimensions are 10. Okay, so that's equal to that, which is equal to that. Okay, find the angle between the diagonal A to B. So if we had a stick or something in our cube, what angle does that make? And the edge BC. So our edge BC is there. So I want to know, this is my unknown theta. Okay, I know I have a right triangle here. Okay, and that is a right triangle there. So if I redraw this, so I have A, B, there's my diagonal, comes down to C, and then C goes across here, right? Well, BC is a side, so I know that's 10. My right angle's here, and I want to find this theta. Okay, in order to find that theta, I need to know at least one other side. So to find that side, I need to find AC. Well, I'm going to look at this triangle on the base of my triangle. Okay, and there's a right angle here. So I have another sub-goal here. So if this is A, let's call this point here D. Okay, D, and to C. So this is the bottom of our cube here. There's a right angle there. This is 10. This is 10 because they're the side of our box. Okay, so if I need to find AC so that I can use it over here to help find my angle, well, I can use Pythagorean theorem. So I get 10 squared plus 10 squared equals AC squared. Okay, well, I get 100 plus 100 is equal to 200 is equal to my AB squared. Well, take the square root, and I get the square root of 200 is equal to AB. Well, square root of 200 can be written as 10 square roots of 2. So, using that information, I'm now going to solve for my green triangle, and I'm looking for an angle. So this is 10 square roots of 2. So identifying, if I'm trying to find this theta, my right angle's here. This is my opposite side. This is my adjacent side. So then I know that I can use, since it's opposite and adjacent, it's tangent. I'm looking for an angle, so it's inverse. The opposite is 10 square roots of 2 over 10. Okay, so as I put that in my calculator, okay, I'm going to find that this is equal to theta, and theta is equal to 54.7 degrees. Okay, so that concludes our notes tonight. Highlight any questions you might have and bring them to class tomorrow.